Hello and welcome. In this tutorial, we will take this dirty text data and wrangle it into this clean form. Having the data in a clean form can help in directly answering some data analysis questions or even produce simple plots like this one. We will learn useful data preprocessing skills using Pandas, a data manipulation and analysis library built on top of Python programming language. We will learn how to think through and implement data cleaning tasks in Pandas. The focus is to gain a good understanding of data manipulation. So when I write a line of code, I hope to explain in a way that someone with limited experience can follow along. Remember, Python or Pandas is just a tool we use to implement our thought or hypothesis about the data. What is important is the thought process, which involves how we formulate what we think is right and how we justify that formulation. This is all the code we need to wrangle the data, but I want us to write the code with meaning and understanding. I will be writing the code interactively in Jupyter Lab. However, you can use any IDE that works best for you. Make yourself a new workbook or script and let us start. To tell Python we want to use the methods, functions, and objects that come with the Pandas module, we use the import keyword to expose the module in our current workspace. We optionally give it an alias as PD so that we do not always use the full name Pandas when referring to the imported module. We can use the keyboard shortcut Shift+Enter to run a cell or a chunk of code. All the functions or methods I will use will come from the Pandas library, and the dir function can help see some of the properties and methods in the Pandas library. This is our data. It is a comma-separated file, and we need to find a way to bring it into Python. We can use the read_csv function from Pandas. We give it the full path of the file. In our case, just the file name is enough since our current working directory is the same as the directory containing the data file. And since read_csv function returns a data frame, we assign the data to a variable df. What you may want to keep in mind here is that data comes in different file formats: delimited, Excel, JSON, and even from databases. Pandas will likely have a function that can help you read the data. We can use the head method of our data frame to access the first few records of our data. Our data has two columns labeled as description of emergency and title of emergency. Let us also invoke the info method to get a concise summary of our data. We get to know that our data has 7,916 entries or rows and 2 fields or columns. All the columns are of object type or strings. Knowing the data type of the columns in your data frame will at least help you limit the type of aggregation you can do with the columns. For instance, you do not want to be performing arithmetic with columns that are not numeric. The info method also tells us if there is a column that has missing values, but we can explicitly check by summing the null entries in each column. Our data in its current form contains no missing values that we must worry about how to treat them. We may be interested in knowing, for instance, how many of our emergency records are fire-related, but that information is not readily available. Our title of emergency column has 2 features bundled up as one column. We want to split that column into 2 columns, emergency type and subtype. One column telling us whether an emergency is EMS, fire, or traffic related, and another column with the extra information provided. I will select the title of emergency column and give it a name too. Pay attention to the double bracket used in selecting a column. This gives us a data frame. If we had used a single bracket, the output would have been a Pandas series. This column selection is not needed, but I am doing so in order to exclude the other column from the output so we can focus on just the selected column. Suppose we assume that the emergency type and the subtype are separated by a colon. For instance, for the first record, EMS is separated from back pain injury by a colon and a white space. This is just one record. We do not have the luxury to inspect all the records one by one to find out if indeed colon is the separator. We must find a way to verify our assumption that a colon separates emergency type from a subtype. We can just go ahead and split the title of emergency column using colon as delimiter, and based on the results of the split, update our knowledge about the data. But here, I want us to reason to the solution and not from the solution. It is a good idea to be sure that colon occurs only once for each record. Also, if colon separates emergency type from a subtype, then there must be some text before and after the colon character. In other words, colon does not appear at the beginning nor the end of a record. Establishing this will help us know the number of new columns we will get when we split the title of emergency column, and know if splitting on colon will affect all the records. We take the title of emergency column as a series, so we use a single square bracket and count how many times colon occurs in each record using the str.count method. We see that it is as if colon occurs once in each record. If we should see a count of 0, then it will mean no colon is present in that record, and a count greater than 1 would mean more than 1 colon present. We can use the value_count method to simplify our count. Indeed, colon occurs once in each record, and there are 7,916 of such occurrences, which is the same as the total number of records in our data. This means all the records can be split using colon as a separator. You may want to try the str.contains method and see how you will interpret the output. Let us do one more investigation. We take the series again, but this time we want to find the position or location of colon in our record. So we use the str.find method and count each position we find using value_counts method. Run it and we see that a colon character can occur in 3 possible positions: the 3rd, 7th, and 4th positions. This means that there are some characters that come before the colon character. Remember, Python index starts at 0, so if we had seen 0, then it would have meant colon occurs at the beginning of a record, and thus not separating an emergency type from a subtype. The numbers 3, 7, and 4 we see may correspond to EMS, traffic, and fire records respectively, but we do not know that with certainty. Also, we have not established that colon does not occur at the end of a record. We can easily extract the last character if it is a colon and count how many of such records are in our data. Note that the $sign is a regex for end character, and we put the pattern colon followed by the $sign in a parenthesis because the str.extract method requires that the pattern be written as a captured group. We get an empty series, meaning there is no record with a colon as the last character. Now we know it is okay to split the title of emergency column using colon as a separator, and the split will result in just 2 columns. We will create two new columns and call them type and subtype. We then split the title of emergency column using colon as a delimiter. We want to get a data frame when we split, so we set the expand parameter to true. Let us run this code and we have our data split as expected. However, we see that some of the subtypes have dash at the tail end, and of course there are others with a dash in between. We want to clean the subtype column by removing dash only when it appears at the end of the string. So we take the subtype column and update it by stripping the rightmost dash character off. Pay attention to the str.rstrip method. It looks at the rightmost character and removes it if it is a dash. We have kept the dash within the text and removed those at the end of the text. You may want to use a regular expression to find last characters, the $, and think of the problem as replacing the last dash character with nothing. Either way, the result will be the same. Still on cleaning the subtype column, we need to capitalize it and remove any extra spaces that may appear in the text. The str.strip function takes care of the extra spaces, and str.title function will capitalize the string. If we check again, we have our title of emergency in the form that we want. It is quite presentable and readable this way. We can now answer some simple data analysis questions like how many records are EMS related or fire related. Using the value_count method on the emergency type column gives us this information. We see that most of the emergency calls are EMS related, and we can even visualize the values using a bar plot. There we have a nice plot showing the bars of our emergency types. Now we can turn our attention to the description of emergency column. We will select only that column as a data frame and assign it to a variable though. Let us familiarize ourselves with this column. Data familiarization can help us discover some patterns. This column has the address of the emergency location, the city, the station where the ambulance or fire truck was dispatched from, and the date timestamp of the emergency call. It appears the data elements are separated by a semicolon. Please keep that in mind when considering splitting the column. However, realize that the date timestamp can occur at the end of the description or within the description. There is no unique order to which the date timestamp appear. Also, the station names come in different forms. Some are just numeric, others are alphanumeric. Basically, this column has a lot of features we will need to isolate. This is where regular expressions become handy. To extract the station name, for instance, we need to understand its pattern and position within the text. We see that what comes before station 332 is the string station and a space. The substring before ST827 is the string station and a colon. Also, what comes after the station name is a semicolon. Can you think of a regular expression we can use as a pattern to get the station names? This is my solution, and I will explain what is happening. First, the idea that the station subtext in our text is followed by either a space or a colon can be described using this pattern. We put the space character, that is \s and colon in a square bracket to indicate either of the two. And since the station name can be alphanumeric, we can represent that with the word character. That is what the \w means. The asterisk after the word character means 0 or more characters. Any non-word character that follows, like the semicolon in our case, will be ignored by this pattern. Let us implement this by creating a column called station and extract a subtext from the description of emergency column using the pattern we talked about. Once again, the str.extract method of a pandas series expects that the substring is captured as a group. Therefore, we put parentheses to enclose the pattern. When we run the code, this gives us the station name with the substring station appearing in it. And for records with no station name, we get none. The string station appearing in the station column is redundant. It only helped us to get what we were after. We need to find a way to remove it for each record. We saw the str.replace method earlier, and we can implement the same using this pattern. Realize that I specified only the station and the space or colon as the pattern I want to replace with nothing. This should give us what we want, and indeed, viewing the DataFrame again, we have the station names only. However, the issue with this approach is that we first extracted a substring that had the string station using this pattern and later wrote another line of code to remove it. This is a kind of a two-step process: create and then destroy. What do you think would have happened if we had captured the word character separately so that we have two groups instead of one captured group? Try it out. It should result in two columns that we will have to drop one and keep only the station name column. And that will still be a two-step process. We can use a single step to get the station names. The simplest way to do this is to capture only the word character instead of capturing the entire pattern. However, I want to seize the opportunity to explore an extremely useful regular expression technique. The substring we are after are the word characters that appear after the station string. In regular expression, we say we want to look around the station substring and get only the word characters. The pattern is this. It is the same as the pattern we saw earlier, but this time there are other special characters. Question mark followed by less than or equal to. That is a look ahead assertion which says only get the alphanumeric character provided what is behind it is the string station followed by either a colon or a space. Thus, it looks for the alphanumeric character only when there is something before it, and that something is the word station and either a colon or a space. Just as before, we create a new column called station by extracting a subtext from the description of emergency column using this pattern. Run it, we get the same result as before, but this time we did so with a single step and with a robust regular expression. The take-home is to think of alternatives to write simple and concise code when possible. In a typical data preprocessing task, we will not only be interested in getting the stations from the description of emergency column, but the address, the town, and the date timestamp as well. Before we look at how to get all that, first, let us count how many semicolons are in the emergency description column for each row. Remember, we did something similar when splitting the title of emergency column using a colon as separator. Let us get our description of emergency column again. We will select the description of emergency column as a series and count how many times semicolon occurs in each record. Realize that I have added the unique method just to get the distinct occurrence of semicolon. We see that some of the records have 4 semicolons and others have 3. This means when we split on semicolon, there can be either 4 splits or 3 splits. Knowledge of the maximum possible semicolons will help us in our next task, so please keep that in mind. We can consider the semicolon as a separator. That is, the semicolon separates each of the data we are interested in, though the data might not necessarily be in the order we like. Remember, for some records, the date timestamp occurs at the end, while for others it does not occur at the end. Let me write this piece of code and I will explain what is happening. Split the description of emergency column using semicolon as delimiter. The str.split function takes other arguments. One of them is number of split positions. Let us set n to 3. We saw that some records have 3 semicolons. Also, we will set expand equal to true to get a data frame as the output. Let us run it. It seems to give us all the pieces of data we want. However, it is just a coincidence because in our data, the last occurrence of a semicolon is at the tail end of the string. If we stick with this, we must find a way to remove the tail end semicolon. If we want the maximum number of splits, we can set n to 4. But there is no need since the str.split method by default splits by the maximum non-adjacent occurrence of a delimiter. Let us run the code again. The semicolon at the tail end is removed, but there is one more column added which shows none for a row that has 3 semicolons instead of 4. But that is okay. We can drop that column later. We also see that Pandas uses range 0 to 4 to name our new columns. Let us call our new data frame desk and run it again. Now we have the address and town as columns 0 and 1 respectively. However, with some of the records, the date timestamp that are supposed to be part of column 3 are part of column 2, and in those instances, we see the station is after the date timestamp separated by a dash. Let us create a new column, call it datetime, and remove the station substring in column 2 using this pattern. We have seen this pattern before with just a little twist this time around. The question mark after the dash character stands in for no or single dash character that may appear before the station substring. If we run that piece of code, we should have what we want. Our date timestamp component is now split into 2 columns. We need to combine or unite column 3 and the datetime column we just created using the plus operator. We give the resultant column the same name, datetime. If we run this cell, we should have all the date timestamps in a single column. Next is to extract the station name from column 2. We earlier saw a pattern for extracting station names, and we will stick to this regular expression. Run and check one more time and everything looks perfect. Now that we have what we want, address, town, station, and date time, we can drop the columns we do not need, columns 2, 3, and 4. We set the axis to 1 to indicate it is a column that we are dropping, and we want to modify the data frame in place instead of creating a copy, so we set in place to true. Let us also rename column 0 to address and column 1 to town. We are getting closer to what we want. Next is to remove the @ symbol in our datetime column. We can run it to see the output. It's looking good. Also, if we run the info method on our disk data frame, we see that the datetime column is an object type instead of an actual datetime data type. Looking out for the data types of the columns in your data frame is part of data cleaning. We can format our datetime column as date instead of string. To do this, we make use of Pandas toDatetime function on our datetime column. Let us get the info again and then run the cell. Now we have our datetime column as datetime 64 data type. And that is what we want. Finally, we can check our desk data frame. We have a clean description of emergency split into address, town, date time, and station. We have successfully cleaned the data and it is now ready to be transformed or analyzed. I hope this tutorial adds to your knowledge in data science using Python programming language, especially how to use Pandas for data preprocessing. Thanks for watching.